Before a designer even starts to lay out a board, they may have several questions that can be answered with a pre-layout analysis tool like LineSim. They may ask themselves, what type of stack up should I use? What type of trace width will give me a 50 ohm characteristic impedance? What type of trace-to-trace spacing do I need to mitigate the effects of crosstalk? Do my traces need termination? So all of these questions can be answered in Hyperlink's LineSim, and we'll take a look at just a few of them. So the first stop of the engineer and designer will be to decide upon a stack up. And we have a stack up editor in Hyperlinks that you can add certain trace widths over here, thickness of each layer, dielectric constants for each layer, and they can give you an idea of the characteristic impedance, and you can start planning that and planning the stack up as your first step to the creation of the board. Once you've decided upon a stack up, you may ask yourself, what will happen if I have a driver here, a transmission line, and a receiver? If I send a signal down the line, what will I see at that receiver? And you can do that simply in Hyperlink's LineSim by doing an interactive simulation. So here I have just an oscilloscope type view, and I want to look at the waveforms on signal U1 and U2. So to do this, I'll expand U1 and I'll expand U2. And let's take a look at what type of signal we get. I'll send a rising edge down. So here we see lots of oscillations in that signal. So that one's underdamped. We may need a termination to properly damp this signal. So let's investigate what type of termination we may need. So I've made a similar circuit with U9, a series termination of R2, and U10. So we'll run a sweep to see what type of termination will be ideal for this circuit. So R2, I have a sweep of 5 values from 0 to 100, each going at an increment of 25. So let's say OK here, run sweeps, and this one was U9 and U10, so we'll get out of there. And let's look at U9 and U10. And we will run a similar simulation. Let's fit that to the view, and let's go and zoom in just a bit. Maybe even a bit more. Here we can hover over each and see this one's the 100 ohm. This one's 75, this one's 50, 25, and 0 ohms. So we can see the effects of sweeping the resistor. Maybe 50 ohm is the optimally damped situation. Now we can look at crosstalk with this circuit I've made down here. These two traces you can see are coupled together. If we were to look at the field solver for them, we'd see, okay, their fields do interfere. So we may get crosstalk if we send a signal from U3 that might appear on the input of U6. Let's observe this effect. So here we have U3 and U6. Let's run a simulation. We'll get rid of the previous results. We can see this orange signal here at U6 is receiving plenty of crosstalk, enough to cross a logic threshold. So let's see if we can minimize that using a little bit of the termination we did in the last step. So here I'll add that 50 ohm termination. And let's simulate. I'll keep the previous results on so we can see the changes. You can see that the crosstalk was reduced by adding the termination on the line. So in the pre-layout analysis tool, you can answer several questions prior to even going to layout. Instead of entering your constraints by rules of thumb, you can actually analyze them and get exact values to provide constraints to the layout for a real constraint-driven layout.